All right, so yesterday we were talking about prime factorization. And when you're talking about factorization, you are taking the factors of a number, so those numbers that you multiply together to get that bigger number, and we were breaking it all the way down till we got to just prime numbers. Today, we are talking about least common multiple. When you think multiple, you should think multiply. Oops, and this was my example from earlier. So least common multiple deals with multiplication. So think multiple, multiply. And what we're trying to do is find the number that is the least common between the two of them. So I'm going to show you an example to start. Maybe this will refresh your memory a little bit. So let's do 3 and 7. We're going to find the least common multiples of those two numbers. So multiples, that means we're doing like our times tables, all right? So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, then 18, then 21, then 24. Then let's go down to 7. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, then 28, then 35. Now what you're going to do is look at your multiples and find the ones that they have in common. Then from that, you're going to pick the one that is the least, the smallest number that they have in common. Now for 3 and 7, there's only one multiple that they have in common, and that is 21. So you may have learned that you can just multiply 3 and 7 together to get a multiple of 21, which is true. That gives you a common multiple of 21, but it's not always going to be the least common multiple. So sometimes multiplying like that works, sometimes it doesn't. So you should still try to list them out like this so you can find the smallest number that they have in common. All right? So now we're going to look at this in this first word problem on page 17 in your workbook. This is kind of like a real world example. Think about like when you go to the store and buy hot dogs and hot dog buns or hamburgers and hamburger buns. There's never the same number in the package. And that's really frustrating because then you have to buy more buns to meet the number of hot dogs, but then you have too many buns, so then you have to buy more hot dogs, and you have to go back and forth. But if you found the least common multiple in those packs between the pack of hot dogs and the pack of buns, you'd be able to see how many packs you need to buy so they match up. So we're going to look at an example here that is very similar to that. We're looking at an experiment. Each flower pot will get 1 seed. If the flower pots are in packages of 6 and the seeds are in packages of 8, what is the least number of plants that can be grown without any seeds or pots left over? So what it wants us to do first, this is the first way that you could solve this problem. Make a list of the first 8 non-zero multiples of 6 and 8. And we're going to circle the ones that they have in common. So it started for us, 6, 12, 18. 6 times 4 is 24. Times 5 is 30. 6 times 6 is 36. Times 7 is 42. Times 8 is 48. Then we go down to multiples of 8. They have 8, 16, 24. 8 times 4 is 32. Times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. And 8 times 8 is 64. Now let's look through our list and circle the ones that they have in common. So let's start with 6. I don't see a 6 anywhere. I don't see an 8 anywhere. I don't see a 12. I don't see a 16. I don't see an 18. But I do see a 24. If we keep going, there's no 30 or 32, no 36 or 40, no 42, 48 and 48, and no 56, no 64. So we have two numbers that they have in common, two multiples that they have in common, but the least common is 24. So the least common multiple is 24. So that tells us that they could grow 24 plants and not have any seeds or pots left over if they planted 24 of them. So now we're going to look at another way that you can solve this problem. And I'm going to tell you, I don't love this second way. It makes sense, but it gets a little confusing because they want you to draw a Venn diagram. And that can get tricky. Come on, there it is. So we're using the same numbers, but we're going to use prime factorization, what you just did yesterday. So write the prime factorization of each number. So over here we have 6 and 8. If you need to go off to the side and draw your factorization trees, you can. So the two factors for 6 are 2 and 3. And then for 8, we have 2 times 4. 4 has to be factored again to 2 times 2. So we have 2, 2, and 2 as our factors for 8. Then it says list the common prime factors of the numbers, if any. So if you'll notice, in both 6 and 8, they have the number 2 in common. So we would put a 2 here. Down here in your Venn diagram, place the prime factors of the numbers in the appropriate parts of the Venn diagram. So our prime factors of 6, we have 3, and then we also have 2, which is what they have in common. Our prime factors of 8, we have 2, 2, and another 2, which is what they still have in common. So then we're taking all of our factors, all of our prime factors, and we can multiply them together, and it's going to give us the same answer, that same least common multiple. 3 times 2 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. The least common multiple is 24. So the least number of plants is 24. That's the smallest number they could plant and not have any seeds or pots left over. So if I clear this off, we'll look at another example. So this example, I believe, yes, it's on the top of page 18. It wants us to use prime factorization again to find the least common multiple of 12 and 18. But this time they're not using a Venn diagram. So I think it's a little bit easier this way. So write the prime factorization for each number. So for 12, they started it for us, but now we have to finish. For 12, we have 4 and 3, and then we need to factor it again to 2, 2, and 3. So 3 is what's missing in the blank there. For 18, you can break it down to 6 and 3. 6 needs to be factored further to 2 and 3, and bring the 3 down. So 2, 3, and 3. Now what they did was they drew these arrows to show that they are bringing every one of those prime factors down to be multiplied together. So the least common multiple of 12 and 18 is 2 times 2 times 3 times 3, which is 36. So if we were to use prime factorization to find the least common multiple for those 3 numbers, you would do this same thing. I'm not going to go through this again because this can get a little bit confusing, and I feel like writing out your list of multiples makes it a little bit simpler to see. If you like this way, you are more than welcome to use it. However, I like the listed out way, okay? So we're going to do another example. before we go to our lesson check. 6 and 9. We're gonna skip this one because this is one that's on your lesson check. We're going to do this one, except instead of 5 and 10, if you turn to page 19 in your book, we're gonna do number 2 on page 19. So instead of 5 and 10, we're going to do 3 and 5. Oops, and that went to 9 and 12. We're going to do 3 and 5. So that's number 2. I like to list out the multiples. If you prefer to do the factor trees, you can, but it might be it's a little different because these are already prime numbers. So you can't just multiply those two together in this case. But our multiples for 3 are 3, 6, 9, 12, 15, 18. For 5, 5, 10, 15, 20, 25, 30. So in this case, our least common multiple is 15. We can find the least common multiple in this case by just multiplying 3 and 5 together, but that's not always going to work. So I'm actually going to do another one that you can't just multiply together. How about we do number 7? Let's do number 7. So number 7 is 9 and 12. So we're going to find the least common multiple of 9 and 12. So we have 9 and we have 12. Listing out the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 12, we have 12, 24, 36, 48, and I already see a common multiple. I see 36. That is our least common multiple.